Hello dear students, welcome back to the NCERT science class of 9th standard. Dear students, we are studying the very second topic, that is matter around us pure, in which in the previous class we have studied about the mixture, types of mixtures and solutions. That is, dear students, today we are going to study the second mixture, that is suspension, and third one is here, that is colloidal solution. In the previous class we have studied the first one, that is solutions. There are three mixtures that we are studying. The very first one, solution, suspension, and third one is colloidal solution. Solution we have studied. Solution is a homogeneous mixture of solute and solvent. See the example, by dissolving salt in water, the salt is a solute, water is a solvent. When we dissolve the salt in water, then what happens? It forms a solution where the solute particles completely gets dissolved. See, I am having one solution and I have added the salt part, salt, where the salt is completely dissolved. Salt is completely dissolved. See here, I am having the salt solution. I have added the salt, and when I stir it well, the whole salt will get dissolved. See, I will not get any solute particles of salt, and I will not see any solute particles in the solution of salt. Salt particle I will not see, never I will see when it dissolves. See, when it completely dissolves, I will never get the solute particles or the salt particle in the salt solution. See, salt is a homogeneous mixture in which solute particles are completely gets dissolved. You will never get the solute particles. You will never identify the solute particles when the solute particle gets dissolved in the solution. Yes, that is an example of solute, that is solution. That is a homogeneous mixture in which the solute particles gets dissolved in the solvent. Next, dear students, today we are going to study the another example, another solution, that is another mixture that is called as the suspension. Suspension is a heterogeneous mixture. You know the meaning of heterogeneous and homogeneous. Homogeneous means the contents are unable to identify. Here the content, that is salt and water, I have added. The salt you can't identify. That is homogeneous means the solute, the mixture in which the particles are unable to identify. See, solute particles are, is it possible to identify? No. But here what happens, dear students? Heterogeneous mixture in which the solute particles are able to identify, are visible. You can separate it by easy method. See here one example I have taken this salt, and that I have taken the soil in water. See, soil that is settled at the bottom. See, soil will not dissolve in the water. Heterogeneous, separate, the contents are there, whatever the components are there, we can identify. See what happens, dear students? Heterogeneous mixture in which the solute particles do not dissolve. We have added the salt or chalk powder, if you add, that will not dissolve, that set at the bottom. When we stir it well, that will be remains in the bulk, and then again when we kept it undisturbed, that will be settled at the bottom. Yes, see what happens? The solute particles will not dissolve but remains suspended throughout the bulk of the phenomenon, the bulk of the solution, isn't it? Bulk of the medium. That is example, soil in water or chalk powder in water, that will not dissolve, that will remain, and when we kept it undisturbed, that will be settled at the bottom, that will never it will dissolve, never it will be dispersed, it will remain settled at the bottom or the remains in the bulk of the solvent, isn't it? That is about the suspension. Suspension means water in the soil in the water, that is called as the suspension. Next we come to the properties of suspension. That is properties of suspension. See, it is a heterogeneous mixture. The content we can separate, the soil we can separate from the water, and soil we can identify very easily. See, the soil particles or the solute particles we can identify, we can separate it. That is called as the heterogeneous mixture. The suspension is a heterogeneous mixture. Next, the particles can be seen by naked eyes. See, that is solute particles I am having, we can see by naked eyes. See here, the solute particles I am having, we can separate it by naked eye. We can see by naked eyes, isn't it? The solute particles, see what happens, dear students? The solute particles we can see by naked eyes. Next, particles of suspension scatter the beam of light. When we pass a beam of light, the beam of light will be visible because the particles are come in the way of beam of light or the ray of light. That's why the ray of light is visible. But when we pass a beam of light, ray of light, it will be not visible because the particles are not visible by naked eyes. Next, dear students, what happens here? The particles of suspension, they scatter the beam of light. See what happens, dear students, here when a particle come in contact. See, suppose for example a ray of light is passing, a ray of light is propagating in the straight line. When a particle come, the larger size particle come in the way of light, then light, what happens? That light will scatter, ray of light will scatter. The ray of light will scatter. That's why the ray of light is visible. That is also called as the Tyndall effect. Later we study. When a beam of light passing through the medium or a solution, when it strikes to a particle, the beam of light will scatter. That scattering of ray of light is called as the Tyndall effect. But here, see here what happens, dear students? Suspension, the particles of suspension scatter the beam of light. Next, here what happens, dear students? The solute particles, when we kept it undisturbed, the solute particles will settle at the bottom. See, you might be seeing that particles that will be settled at the bottom. That is, it is getting settled at the bottom. Solute particle, soil particle is there, settled at the bottom, and next water is remaining upside the layer above the layer of the soil. Isn't it? The solute particle here, the solute particle, layer of solute particle, the soil is there, that layer is there, that settled at the bottom. When we kept it undisturbed for few minutes, that will be settled at the bottom. Isn't it? That is suspension, the particles of the solute or the particles of the solute gets settled at the bottom when the suspension kept it undisturbed. Next, the solute particles can be separated by with filtration. By using a filter paper, when we filter the solution, when the filter the suspension, what happens? We will separate the solute particles, we will get the water, pure water. When we pass through the filter paper or the filtration, then we can separate the constituent particles. The next, dear students, the example for this one, that is chalk powder in water or soil in water, that we have studied. Very easily we can separate the constituent because it is a larger sized particles are there. Next, dear students, come to the next point, that is colloidal solution. See, here I will show one example, that is colloidal solution. Colloidal solution, that is example, we have given ink in water or milk. Take a beaker of water, take 50 ml or 100 ml of water and take 10 ml of milk or 2 to 3 drops of ink, add into the water. Then what happens? Stir it well. Then what happens? After few minutes, after few seconds, the whole ink particles will get present in the bulk of the solution. That gets dispersed. It will not dissolve. The ink particle or the milk particle, that will not dissolve. And that will not settle like a soil, but it will remain it will remain in the bulk of the solution. It will disperse. When we kept it undisturbed, that milk particle or the ink particle I have taken, that will not settle at the bottom. If we keep it for 1 day, 2 day, 3 day, even month together, that will not settle at the bottom. See here, this one is a type of mixture. See here, colloidal solution, it is a heterogeneous mixture in which the solute particles gets dispersed, not dissolves, gets dispersed in a solvent or a dispersed medium. In a solvent gets dispersed, in a solvent not dissolves. It will not dissolve. How the salt gets dissolved in water? Here the ink particle will not dissolve, milk particle will not dissolve, isn't it? Next, dear students, the example is here, the milk in water and ink in water. The next come to the properties of colloidal solution. It is a heterogeneous mixture in which the particles can be separate. It is a heterogeneous mixture. Next, particles can be seen by naked eyes. See, we are seeing the ink particles are or not? Yes, ink particles are visible. Ink particles, because of that ink particles, the solution is blue in color. Yes, ink particles are visible. That we can see the particles by naked eyes, but we can't separate. See, the particles scatter the beam of light. When we pass the beam of light or the ray of light with a torch, the beam of light is visible here. It means it scatters the beam of light. It scatters the beam of light like that. Isn't it? Next, particles do not settle at the bottom. See this ink solution. This ink solution, when I kept it in undisturbed place for few days, that the ink will not settle at the bottom. Yes. Then the solution is stable. It means stable means throughout the solution. Throughout the solution, what happens to dear students? You will get the same quantity of particles, isn't it? The solution is stable. Next, dear students, here some terms are there: dispersed phase, dispersed medium. This in case of colloidal solution only that part terms are coming. In case of solution, solute and solvent, these are the two terms. In case of solution, the two terms are there: solute and solvent. In case of colloidal solution, the two terms are there: dispersed phase and dispersed medium. Dispersed phase means ink particle. Ink particles are the good example for the dispersed phase. Next, dispersed medium, water. See, the solute particle which gets dispersed in a dispersed medium. The solute particle or ink particle that gets dispersed in a dispersed medium or water, that is called as a dispersed phase. The solute particles will be gets dispersed in a dispersed medium or in a water, that is called as the dispersed phase. Next, come to the dispersed medium, that is water which gets dispersed. The water or the medium, the water is a medium in which the ink particle gets dispersed. The water or the medium in which the solute particles gets dispersed are the in which the solute particle or the dispersed phase or the particles gets dispersed. The solute particles gets dispersed in the medium. That is medium is called as the dispersed medium. Next, dear students, here one term is here, that is Tyndall effect. Most important term as point of examination view, most of the times he asks, that is Tyndall effect. When a ray of light, you might have saw on early morning during scenery, what happens to dear students when you went on jogging and all, you might have saw the light ray is coming from the branches of the tree or the canopies of the tree. Canopies of the tree, a huge tree, the light ray is visible, but the light ray is not visible during the afternoon or evening session. In early morning only, the ray of light is visible when it passes through the branches of the tree. See, it is just like a columns. When on early morning, what happens? More amount of water droplets are present, or humidity is more on more morning. See, when the ray of light strikes to the air water droplets, it will scatter. That's why it will appear like a column, isn't it? That is called as a Tyndall effect. That is scattering of ray of light when it passes through a medium. When it strikes to the surface of the particles, the scattering of ray of light, that is called as the Tyndall effect. The process of scattering of ray of light, that is called as the Tyndall effect. You might have saw the hole at the roof. That is in the kitchen. Maybe you saw that the dust or the smoke particles, when it come in the way of ray of light, the ray will be visible. Otherwise, in other halls, you will not get the ray of light, isn't it? Next, dear students, here the most important term. Here dispersed phase, we are thinking that dispersed phase should be solid. No, dispersed phase may be solid, may be liquid, may be gaseous. Dispersed medium may be solid, may be liquid, may be gaseous. Isn't it? Depending on that, he has given in our column. In your textbook they have given one table, complete table he has given. Next, dear students, we are going to study the most important another concept, that is difference between the solution, suspension and colloidal solution. The most important, that is solution, suspension and colloidal solution. Solution, suspension and colloidal solution. Difference we are going to learn now here. See here what happens, dear students. First, solutions. Solution, suspension and colloidal solution. Solution, suspension the third one is colloidal solution. See, solution, suspension, difference we are going to learn. Here the constituents are solute and solvents. Solute and solvent. Here also, that is solute and solvent we can say. Solute we can't say, that is solute and solvent we can say. Then here dispersed phase and mediums. Phase and medium. Next, see, particle size. The example first we have to say. Salt in water. Salt in water, the example best. Here soil in water. Next, here ink or milk in water. See here